All right, good afternoon, and welcome to today's webinar. It's titled 10 Reasons to Modernize Your Press Controls and Future-Proof Your Operations. The webinar is presented by Toledo Integrated Systems and hosted by Metal Forming Magazine. I'm Brad Kuhn. I'm the editorial director here at Metal Forming at PMA, and I'm pleased to be your moderator for today's webinar session. Before we get started, just a few notes about today's session. This meeting is being recorded for archiving. And the recorded event will be posted to our website within the next few days. So we'll let you know via email when the recording is available for viewing online and perhaps sharing with others at your company. Also, all of the participants in the meeting are in listen-only mode, which means that our presenter and other attendees will not be able to hear any audio from your site during the program. But you can communicate with us throughout the program. You'll just submit any questions and comments to us and to our speaker using the question box located in that control panel on your Zoom screen. If you don't see the Q&A button, you'll just click on the More button, and then you'll see the Q&A panel appear. So then you'll simply type your question to an organizer, and then you'll use that same question panel to ask questions of our speaker at the end of the presentation. All right, so it's time to begin today's webinar. Aging and obsolete press controls limit flexibility, increase downtime, and can drive up long-term costs. During the webinar, we're going to break down 10 key reasons why modern standardized press controls featuring state-of-the-art OSHA and ANSI-compliant safety systems and all-in-one total line control solutions will enhance safety, boost efficiency, and support long-term performance. Our speaker today is John Eby. John is the sales manager at Toledo Integrated Systems. So John, the floor is yours.
Well, thank you, Brad. Again, John Eby with Toledo Integrated Systems, and as Brad said, I am the sales manager. So just a quick history on myself. I started working here at Toledo Integrated Systems about just over 30 years ago. I started as a technician troubleshooting tonnage monitor boards while I was going to school at the University of Toledo getting my engineering degree. After I graduated, I was asked to stick around, and I was a controls guy for quite a few years. And fast forward to now, I am the sales manager. So I've definitely seen a lot, but I haven't seen it all yet. Every day is interesting challenges, and I love my job. So as Brad mentioned, we're going to talk today about 10 reasons to modernize your control systems. And we're going to go through safety and all the different advantages to having modern control systems. So why modernize? Aging control systems create risk and inefficiency. There's an increasing demand for flexibility and data, and I'm going to talk about these later in the presentation. Another reason, the cost of downtime and obsolete components is rising. The need to update to meet modern standards and technology. Our world is changing, and the old systems just aren't cutting it anymore. So jumping right into it, number one, improve safety and compliance. So the picture on the left is a beautiful picture. And it's amazing how often I go into these companies, and it may be some of yours, where you open the box and the wires kind of spring out at you. And I just sometimes wonder if my job was to make this thing run, where do I start? I will ask customers, can I get a copy of your current electrical schematics? And sometimes I'm told they don't have any. Sometimes I'm told there's pages missing. And then every time I'm told they're not accurate. And is this what's protecting your employees? If it's, if you don't have good information, how can you troubleshoot? How can this be safe? Definitely one good reason to improve or modernize your controls is to improve that safety. So stamping press lines, they have very specific rules from OSHA, ANSI, and CSA. I listed out the regulations there, and they're available, some for free, some for purchase. But in going through those regulations, they talk about component safety from mechanical things, from preventing hazards from mechanical breakages, releasing stored energy, the importance of a dual solenoid clutch brake valve. They talk about safeguarding and interlocking. What's good if you have a safety device that's not interlocked, that can be easily removed and defeated. They talk about control systems and design requirements, specifically for clutch brake control. Basically the control of the motion, the part that can hurt somebody. They talk about anti-tie down, anti-repeat, key things with presses. Anti-tie down is a way to defeat a control system for a press. In older systems, very easy to do. Modern systems, not nearly as easy. Anti-repeat, it's a protection against a failure in the control. We talk about control reliability and e-stop circuits. In addition, point of operation guarding, the different modes. So they give very specific details on how to design those systems. Well, they're detailed, but yet they're general, I should say. But additional items that are covered: counterbalance and clutch air monitoring, your safety distance. There's many more. Those particular regulations are quite a few pages long. So some things to consider when improving the safety of your stamping lines. So guarding the point of operation. Are you going to be using physical guards? Are they fixed? And if you're using a fixed guard, they need to have be mechanically tied in, so not a normal tool would be able to release that. Or are they interlocked? That's tying into the control system. Is the control system able to take in that interlock signal? Are you using presence sensing devices such as light curtains or scanners? Again, do you have a system that can use that modern devices for protection? Two-hand controls, maybe on a smaller machine, that is what you're using as your primary guarding. There's a specific ways to monitor those two-hand controls that are talked about in the regulations. If we talk about control reliability just for a quick second, if you boil it down, what that means is that no single fault can cause it to fail. So if a fault happens, the system will stop until the problem is corrected. An example would be a dual channel safety. So on a dual channel safety circuit, if one channel fails, you still have the secondary channel making it safe. And then it will not be able to reset until both channels are happy. That's the simplified version of control reliability. Other things to consider would be energy control. Everyone talks about lockout, tagout, but what does that really mean with your controls? So die plug blocks is an example. How it's supposed to work is when I pull the die plug out, should be electrically interconnected to the control. That should basically prohibit motion and kill energy sources, which would main motor, all your motors. Basically, it's a master stop situation. That would be an example. Other things to consider: risk assessments and safety levels. Are the existing controls truly safety rated? Using risk assessment tools, they help identify what safety level is needed. And in the next slide, I'm going to talk about the category level, the performance level, and the SIL safety levels. So category levels is really how the safety system is designed. The higher the level, the more safe it needs to, more safety it is. SIL is the probability of what if that safety will fail. So the amount of risk determines what safety levels are needed to be met. The higher the risk, the higher the level. An example of a difference in category level. So if I use my e-stop circuit and I wire them in series, I'm at a category 3. So basically, everything's in series. If I want to wire those individually into safety inputs on a safety PLC, that would help me achieve a category 4 level. So number two in my reasons for modernizing is to eliminate obsolescence risks. So here, Mr. Manager, the 1960s called, and they want their press control back. It's amazing how many companies are still running the original controls from the 60s or whatever year. If we think about it, that's 60 or 70 years ago. And they're still running, which is great, but I'm sure something in that control has been modified, and the original safeties that were in place in the 60s is not there, but it's not even close to being modern. So what are some of the driving reasons for part obsolescence? I found it in this little article. I found in 2025, over 620,000 parts were discontinued, which is a third more than in 23. Obsolescence is growing even faster. And why is that? As they list here, number one, technology. So basically, the technology is growing so fast. If you think about it, when I was 16 years old, the car that I drove compared to what I can go buy now is just absolutely night and day difference. And part of that is the components that go into the car. And this goes the same for control systems or any other kind of electrical systems. And they're talking about the semiconductors having a lifespan of 2 to 5 years. And we're comparing this to a control on a press that might be 60 years old. Shorter production life cycles. Corporate restructuring and mergers. So as companies merge together, they're discontinuing their legacy products, which helps maintain their bottom line, but does not help the guy that has the older components. And then, of course, you have the geopolitical and economic shocks. So tariffs and all the fun things that are happening right now in the world, they really disrupt the supply chains. Regulatory and compliance pressures. So aerospace, medical, they continually are asking for more and more higher standards in their requirements, which phases out the other stuff. And then absence of product change notifications. Basically, as things are improving, no one's telling anybody, and that's causing even more of a problem. So the electronic component obsolescence is one of the biggest threats to supply chain stability. Companies need to strategize before it impacts their production lines. So risks would include hard to find or discontinued components from suppliers. One of the jokes that's always being said is eBay is out of stock. Sometimes it's not even, you don't even bother calling your vendor because that component's been obsolete for so long. You're searching on eBay and other sources like that, hoping they have it. Another risk, unplanned redesign for components that cannot be sourced and expediting fees that go along with that. Okay, there's no way I can find this part. Now I have to hurry up and make a quick fix and then rush it in here once I figure out what I need. Every day, newer technicians are coming into the field working and being asked to support older equipment. I could only imagine having a guy straight out of college trying to support a relay panel. He's not taught that in college at all, and he might be very smart, but that's going to take extra time for him to learn how to troubleshoot stuff like that. The lack of or poor documentation. Having an older PLC that's 30 years old, trying to find documentation on that is going to be quite the challenge, just so you can start troubleshooting. All of which leads to higher risk of extended production outages. If you're spending time just trying to find information to figure out what's going on, it's definitely not getting the machine back up and going. You got to find that information before you can even start. And then the risk of all of it is having unhappy customers because you're not able to run their parts. And then technology is moving faster every day. In the picture there, just think about how many cell phones you've had since 2000, 2006 or whatever. I'm amazed how often the tech, just in the cell phone world, how often we are going through and updating phones and other things like laptops and whatnot. My third reason for modernizing is reducing the downtime cost. So with having a modernized control system, we are able to faster diagnostics and troubleshooting. We're able to improve system reliability, quicker availability of components. Inevitably, something's going to fail. But if you have something that's relatively new, the chances of finding that and finding it quick is higher. Newer systems have remote access capabilities using things like EWANs. And if you're a larger company and you are relying on a few corporate engineers, components like EWAN allow them to troubleshoot remotely rather than being right in front of the machine. Less unplanned downtime, lower cost of production interruptions, and then probably one of the biggest things, someone to call. Old systems, they have no documentation. They have no one to call. You have no one to call when you need support. You need to figure that out yourself, which takes extra time. My fourth reason, standardization across the plant floor. Just imagine having the same control system on all your press lines. What that would do just for your throughput and your maintenance being able to maintain all those pieces of equipment. Being able to move an operator from one press to another or plant to plant has huge benefits. Without standardization, operators need to know how to run multiple control platforms. Many times, almost impossible. When I go and visit companies, I'm told Joe runs this machine because he can't run the other one because Joe knows this machine. But Bob can't run this one because Bob knows that machine. If Joe could run both and Bob takes a vacation, it's the best way to have efficiency. Training costs are reduced with both operators and maintenance. Maintenance they're able to react quicker, smoother. If they just need to know one platform across the way, it's easier for them to troubleshoot when something happens. If they have to remember a different system for each machine, that is just going to take more time. With standardization, you're able to stock spare parts that can service all the press lines. If you have 10 different lines or 10 different systems, it's very hard to stock 10 different things for each one. And having a common control can definitely reduce your spare parts risk. Reduces the risk of inconsistent safety in older versus newer press lines. Basically, what I'm trying to say there is if I have a press control that's from the 60s and I buy a new press, they're going to act different. They may be confusing and inherently dangerous because of how they are different. If you're trying to use an operator from one to the other, one press may react this way, the other acts differently. That could be a problem. You can have better vendor and OEM alignment. If you're going to buy a new piece of equipment, you would tell the supplier, these are my standards. It would come in with basically a look and feel very similar to what you already have on the floor, less avoiding every new machine I get is different, which can cause additional problems. Increase the fifth reason for modernizing, to increase operational efficiency. I've never heard anyone say I've updated my controls and now I can't run as fast. Usually I hear quite the opposite. I've updated and things are just running much more smooth. So using modern automation and data helps achieve this. Gives me faster processing and control response. improve throughput and consistency, better overall equipment effectiveness, optimized machine performance, and more efficient maintenance troubleshooting. You can tell just by how happy these guys are. Number 6, reduce setup and changeover times. So just looking at that picture in the middle there, if I count them out, 1, 2, 3, it looks like 6 or 7 different systems there. Are we trying to get to the moon, or are we just trying to run a press? I'm sure with every new thing that they needed, they added another box. But now, where do I start when I have a problem? Which one's causing my problem? Definitely, and on your changeover times, do I need to change something on every single one of those boxes? It just all takes extra time if your control looks like that. Modern controls allow for more automatic functions, faster adjustments and configurations, easier integration of tooling changes, supports frequent product or die changes, recipe management, things like that. Less reliance on manual intervention. And then if you're considering updating, you could look at systems like our Maximizer TLC, Total Line Control. So instead of just putting a control on the press alone, there's a good chance that the press and the feed line both have older controls. Controls like the TLC can actually have one brain that controls the entire line. So what you have is a well thought out solution for not only running the press, but also the feeder, the straightener, the uncoiler, and even the transfer system. It could be all tied in. Today's controls are powerful enough with one brain can run the entire line, which at the end of the day, if you have a problem, that's one phone number for support. How nice would that be? Number 7, improve maintenance efficiency. If you take care of maintenance, they're going to take care of production. I haven't met too many maintenance guys that they want to improve things, but a lot of times the headaches of old stuff really can get them down, like this guy. Investing in modern controls is the same as investing in maintenance. It's giving them the tools to do their job better. It's helping them identify problems faster, improves diagnostics and alarm clarity. It reduces the troubleshooting time. It increases overall maintenance effectiveness. And probably most of all, it boosts overall maintenance work morale. Having newer controls is going to have less stress, which in a weird way almost feels like more money in their pocket, because everyone knows what stress does to you. Less stress can also lead to less turnover. If they're going to work and have a headache every single day, they're going to get wore out. They're going to start eventually looking for another job. Improving, modernizing, giving them tools to do their job is helping with their morale, ultimately doing a better job for you. Next reason for modernizing is enabling flexibility for future needs. And here's a very old picture, but boss, I know you want me to add automation, but these old controls don't have the capability. You have to, if you want to add something, a new widget to take care of a customer demand, you got to have the controls in place to be able to do that. As one customer put it, we always seem to be in some need of an extra control feature to run a die. Looking back at that previous picture where I had all the different systems on there, I think that customer, and like many, well, we're just going to buy another box and we'll just add it on there. Rather than having a modern control that has some spare I/O, you can program in an additional feature to take care of the customer demand. Helps to adapts to evolving customer requirements. Modern controls allow for future changes that don't require costly redesigns and retrofits. They add flexibility to help future-proof the stamping lines, which updated controls equals smarter decisions and stronger maintenance. Number 9, leverage Industry 4.0 and data. So now we're starting to manage by facts and not opinions. Everyone's Industry 4.0 has been a buzzword, and a lot of people ask what it means and how do you achieve it. And I think a lot of companies are really trying hard to figure it out, and some are doing better than others. But it refers to the integration of digital technologies into manufacturing and industry, things like smart machines, connected systems, and real-time data. So leveraging advanced controls and data-driven insights to enable predictive and autonomous maintenance. So smarter, more efficient operations. With tools like the Internet of Things and sensors on equipment, factories can monitor performance in real time, reducing downtime, improves productivity, and cuts waste. So there's a big push for predictive maintenance. And that sounds great. You have the machine tell you that I'm starting to fail. And that's really what it is. We're going to put sensors on everything. We're going to send it up to the cloud. We're going to let these big data companies do their magic. And then the goal is that the system is going to tell you that my bearing is going to fail within the next X days, X weeks. So that way you can have planned downtime. Without modern controls, there's nowhere to plug these sensors in. There's nowhere to get this information out of to even think about starting to do something like this. And there's different levels of industry, in my opinion, different levels of Industry 4.0. There's walking and then there's running. Walking is putting some sensors on there, monitoring some of the heavy hitting things that can cause problems, maybe monitoring your bearings and things like that. And then there's running, which is taking it all to the cloud and trying to be proactive. But until you have a modern system, we can't even start to think about something like this. So my last reason is extending the equipment life. So we talk about the controls, they're aging fast, but mechanically, the mechanical parts don't go obsolete. The older piece of equipment, the bearings can be rebuilt. They can outlive the controls, until the entire machine becomes uneconomical to maintain. That's when it's potentially the time to replace the mechanical portion. But the modern controls prolong the press line usability. It delays the full capital equipment replacement. The cost to replace the entire line is extremely more expensive than just updating the controls and maintaining the mechanical aspects, which allows you to maximize your return on existing assets and maybe planned for down the road replacement. And then the recommended life cycle for control upgrades is around 20 years. More often than not, the controls I'm running into in the field are far more than 20 years old. So what is the cost of doing nothing? You have increased downtime from obsolete components. You have rising maintenance costs because you're spending a lot of extra time trying to figure out old stuff. You reduce productivity and efficiency. And then your lost opportunities from lack of data and flexibility. Maybe your customer is asking you to do something that you just can't do with that old system. By not updating, are you throwing money out the window? Yeah, you might be saving a couple dollars now, but what are you losing from not updating? So in conclusion, modernizing control systems is not just an upgrade, it's a strategic investment in your safety, your efficiency, reliability, and your future growth. It's time to reduce the risk before it's too late. And I want to thank you for your time, because time is valuable. And thank you.
Excellent, John. Thank you for that. Boy, you covered a lot a lot of stuff in a relatively short time. If anybody has any questions for John, please fire away using that Q&A panel. I do have some questions for you, John. Like right off the bat, you mentioned are your press controls safety rated? How do you even know if the press controls that you're running are safety rated?
There's probably a number of different ways to answer that question, but a good place to start is, you know, when you open the panel up, does it look like the picture that I showed to begin with? And
Okay.
do you have drawings that even match that? I mean, if you don't have, if you have a wires nest in prints that don't match or don't have prints, it's going to be very hard to determine. I'm going to say it's probably not.
Okay.
But then if you have a more modern system, there's other, for instance, you talk about control reliability. If I open the panel and I see a single non-safety PLC running a machine, that's a big no-no. That is, it can do the job, but if you go into those regulations, it specifically says that's a no-no.
Okay.
Yeah.
Okay. And then you showed some different categories of safety level. What is the safety level required or recommended for stamping presses?
A lot of it turns on how much risk you have with your line. So typically you're going to be in a category 3 or a category 4 type situation. But
Okay.
doing a full risk assessment or a basic risk assessment, that will help you determine what level you need to go with.
Okay. And are those two categories, 3 and 4, significantly different?
Um, yes,
Okay.
they are. They're both acceptable, and a lot. Well, I should say they can be both acceptable depending on how they're used, or I should say where they're used.
Okay. So probably a hard question to answer, but the typical line control upgrade, how long does it take? Are we looking at a week or two, something like that?
Yeah. So our rule of thumb, if I just, let's just say a 500-ton press with a standard feed line, and I'm going to do what I call the TLC package to update the entire line, press, feeder, straightener, uncoiler. We're telling customers about 14 days. It's going to be, roughly 7 days to rewire, a few days to start, testing all the features, and then we're going to want to get an operator, a coil of steel, and by the 14th day, at that point, we're, turning it over to production.
Do you find yourself doing more of these complete line upgrades versus just attacking the press itself?
We're seeing a lot of times we'll get brought in. Hey, can you my feeder, my drive, it's obsolete, or the press. I got this, and I'll go in and I'll look at the press, and then I'm like, that's great, but did you know you can't get that drive anymore for your feeder? So it turns into instead of if I fix the press and make the press monitor control, I still didn't eliminate the risk because now my risk is the feed line. But if I do the whole thing, now that customer has a solid modern control for 20 plus years.
Yeah. And they're not going to find out about obsolescence until they're in the mix,
Until it stops running.
Yeah, exactly.
And they realize eBay's out of stock.
I got you. People want to know, I guess, what's the typical cost for doing a total line?
Yeah, that's a great question. Everyone asks that question, and it's the magic question. It's very hard for me to say it's X dollars, because even though it's a press line, it's a press, everyone is different, based on what that motor horsepowers, on your feed lines, basically the more difficult material they're running through it is going to require more horsepower in the motors and drives. So it's very challenging to give that number. But the good thing is quotes are free from most companies. They are with us because to make informed decisions, you need to know what it costs. And I sure don't want to say, oh, it's going to be X dollars and be way off, because it's either going to affect me or it's going to affect my customer. I'd rather do my homework, and that way we know what it is, and
Sure.
people can plan accordingly.
Okay. I'm sure there's plenty of press operators, maintenance people who are struggling with some of these obsolete controls and the headaches that come along with them. Who, who do you see in the companies that you deal with as championing these projects? I'm sure something like this takes somebody who really wraps their arms around it and does the calculations and the cost justifications. And is it a maintenance manager? Is it a plant manager? Who's the champion of these types of projects, or does it vary from company to company?
It definitely varies from company to company. What it takes is someone to take charge and take the time. It's the guy that just shows up to work and complains. He's not going to get it done. The guy that shows up and who wants to improve his situation, his coworker situation, that there's real examples. I mean, I share. I mean, my presentation is pretty general, but if they walk around their press shop, there's some real life examples. I mean, you could just literally take a list of all the drives, and just that one little thing could tell you how much risk you have just with that alone. Because if your drive's not gonna, and that's just one little thing, but if your drive's gonna fail and you can't get a replacement, what are you gonna do? Are you gonna tell your customer you can't make parts for 2 weeks? Or you better have a backup plan. Or a lot of times what's happening is that individual that champions that is saying, hey, if I help this machine, I can take those old parts and put them on my shelf. I don't have to rely on eBay so much. And then next year I'm going to update that one. And they just kind of go through, because not too many companies have the money to go through and update all their controls. That's not realistic. But
Okay.
picking them off, as a planned, replacement seems to work the best.
Is that a good place to start then? Just make a list of all the drives that you have, which most people don't have that in their file cabinet at this point. So is that a good
there's some key electrical components. A relay, that's easy to replace. A motor starter, easy to replace with a different part number, a different vendor. But your feed drive, your main motor drive, there's not as much risk with the main motor, but your feed, your motion, there's certain things in there that could really hurt you. And those are the items that should be looked at first.
Okay. You talked a little bit about connectivity, and you even got into Industry 4.0 a little bit too, which is really interesting. But you mentioned EWAN, which I know is a connectivity tool for troubleshooting. Can you explain a little bit more what EWAN is and how it works?
Yeah. So our customers that are primarily more than an hour away, it starts to become even the close ones, but ones that are further away, a lot of times we're able to, from our engineer's desk, get online with the press to help troubleshoot what's going on. And we can usually fix a problem before we could even, if we drove there, we can usually fix it before we could even get there, using that type of technology.
Sure.
And what it is, it's basically an Ethernet connection to that control. Our engineers would pull up the programs on their laptops at their desk. They're able to see inside the brain of the machine.
Okay.
It won't go. They chase it down. It won't go because it could be something simple. Oh, the guy forgot to turn the switch, or it could be this sensor is holding them out, and it would help their maintenance walk over, find the sensor. Oh, you're right. It got hit with a forklift.
Okay.
And of course my example is pretty silly, but it helps them pinpoint potential reasons why that machine's not running way quicker than traveling there.
Sure. And that interface is seamless to the end user, right? It's just installed on the control.
Yeah, so it's a device, and there's other ones. There's definitely other companies other than E1, but they're all similar. That is a device that's inside the panel. No one even knows it's there. When the system is installed, we need an Ethernet connection run to it. That's
Okay.
that's that's what we need the plant to do, and that allows us to get in.
I got you. Okay.
Mm-hmm. It,
Uh,
it's it can be easier than the older VPN type of connections. And every company's got their different cybersecurity. Some allow it, some don't. Um, but we've had good success with it,
yeah.
and most companies approve it.
Mhm. We do have a little bit more time if anybody has any further questions for John. I got one more, and we'll see if anybody else has any. I'll guess I'll put you on the spot a little bit. Uh, you used a term at the end there called autonomous maintenance, which I know what predictive, I know what preventive. What is autonomous maintenance?
So it's um, basically, I think that is where you're really thinking futuristic of machines starting to be able to, uh, you know, I don't think it's out now, but thinking
Okay.
futuristic,
Okay.
basically machines being able to troubleshoot and fix themselves to some degree. You know,
Okay.
it's kind of like cars driving themselves. This is, um, you know, being able. I know my bearing is about to fail. I'm going to go ahead and order myself a new bearing without a person involved.
Okay. Okay.
Things like that, which is hard to imagine, but we're seeing this technology, and if anybody's looking at their computer watching what these robots are doing, and it's really amazing. I just can't imagine in 5 years what's next.
I think there's some reality in that today. Maybe not in the stamping, but maybe it is in stamping already, where the connectivity goes through your ERP system and actually sees if you have this in stock. If it doesn't, it actually triggers an order. If it knows a part's failing, through the maintenance cycle.
And I
Might
think you're
not,
right.
yeah,
I
might
think
not
you're
be as
right.
futuristic as you think. I
Yeah.
just hadn't heard that term before, so that's on me, I guess. Um, all right, terrific. Well, John, again, thank you for a really timely, informative presentation. I hope people took it to heart and go out to their press lines and start making a list of all the drives and other components they have that might put them at risk. Um, to our audience, thank you for attending the program today. We hope everyone found it to be a valuable experience. Again, an archive, a recording of the program will be available on our website probably by the end of the week. So when that's ready, we'll send you an email and let you know how to find it, and you can share it with others at your companies. Um,
Yes.
so,
Thanks again. Appreciate everyone's time.
yep. And thank you, John, and thank everyone for attending. Everyone, you can close your browsers now, and we wish you a great afternoon.
Thanks.